Okay. So today we discuss a one short video of electric charge and field. Okay. This is a summary class actually. So if you want to clear the concept or conceptual classes, that's it. If you want to clear that what is a Gauss's law, detailed discussion, I refer to please refer the previous lecture. Okay. Previous lecture and discuss very clearly actually what is the Gauss's law, what is charge and what is field. Okay. Mm, This lecture actually the one shot video, the summary the all topic to discuss now. Okay. So that we know the two types of charges. First two types of charges. Okay. One is positive charge and is a negative charge. Okay. And there's an attraction between two charges. There's a force of attraction or repulsion. These are force. These force is called Coulomb's law associated to Coulomb's law, and Coulomb's law inspired by Newton gravitational law, and that is equal to A, that is some constant K, Q1, Q2 by R square, it is a vector, R cap direction. And what is the value of K? K that is equal to 1 over 4 by epsilon naught. And K is the Coulomb constant or electrostatic force constant, and epsilon naught is the permittivity of free space. The given the value of epsilon naught, that is equal to 8.854 times 10 to the power minus 12. Okay. So how to find the SI unit? That is F some constant K 1 over 4 pi epsilon naught. Two charges. Actually the modulus of two charges. Okay. Just consider the magnitude, not sign. Okay. Not dependent on polarities. So Q1, Q2 over R square. So that is epsilon naught, that is equal to 1 over 4 pi. That's the unit place value. Okay, that is 1 over A U1 U2 by R square. So SN it is. So the two charges means Coulomb square, and that is force per Newton, and R is the displacement or distance between two charges, that is meter to the power minus 2. Okay. And if you put the all value the K, put this one here, and with the value of K, that is equal to 9 into 10 to the power 9. Similarly, that K, that is equal to Newton meter square. Now the per Coulomb square. Okay. That's the approximate value of K. Coulomb constant or electrostatic force constant. Okay. So these are force and these are electrostatic force. Okay. So actually electrostatic force and experienced by the charge and respect to the another charge. Suppose that is a two charges, consider the plus Q charge and a Q1 charge, another also the plus Q2 charge, and Q1 experience force due to Q2 in that direction, that is F of 1 2. One experience Q1 experience force due to Q2, that is F12, that is equal to some constant K, that is Q1 Q2, doesn't matter their polarities or sign, over R square separation between two charges. These are the separation between two charges, that is R. Okay. Mainly here we know the Coulomb's law and electrostatic force. Okay, these are the force. Okay, these force are attractive force, also the repulsive. Okay, and another concept is called superposition principle. This Coulomb's law also satisfies the superposition principle, means they the algebraic sum of all forces. Okay, suppose there is a force on Q1, Q2, Q2 minus Q3 plus Q4 minus Q5. Okay, the force experienced Q1 due to other charges. Actually, these are for Q, F, 1, 4. These are plus to plus. Okay. So that is equals to 4. F, 1, 2. That is the minus Q5. So that is the actually towards here. Q5 direction F of 1, 5. So Q3 is a minus, so actually it's that side f of 1, 3. Actually, this one refer as a Q1 charge experience force due to Q3. Okay, that's why represent a f of 1, 3. Okay. Simply they are the superposition principle, they just added, okay, f total or f q1 that is equal to f1 2, f1 3, f1 4, 1 5, and so on. There are the some algebraic addition. That's they are the superposition principle. And here we discuss the another concept is called electric field. Field, very important concept here. Electric field. So that is equal to field f 4 by some test charge that is equal to electric field. If that is depend on R, is E also depend on R. Okay, so that is a vector field obviously, because force direction of force are also the parallel to direction of electric field. Both are in same direction. Electric field and electrostatic force both are in same direction. Okay, and these small charge Q represent a test charge. Okay, so that is equal to what is the electric field? Suppose there is a Q1 charge, okay, that is called source charge. Okay, and so you calculate electric field at a point here, point P. Calculate electric field at point P. How to calculate electric field at point P? So the formula says that you bring a test charge here, either positive or negative, and these test charge experience some force. These small test charge experience some force if the test charge placed in the electric field of Q1. Otherwise, if the test charge is not experience any zero force or no force, so means the test charge not belongs to that field of Q1. Okay, so that's why the Q1 test charge placed, a small q test charge placed here, and these small q plus test charge experience a force in that direction outside. Okay, so that force is that is equal to some constant k, Coulomb constant, small q is charge multiplied by source charge q1 by the separation is called r. That is a r cap if you consider the vector. Now, divide by test charge. The force divided by test charge small q divided by test charge small q to cancel, and force divided by test charge will get electric field at point P. Okay. So force divided by test charge, electrostatic force divided by test charge, we get electric field at point. Okay. So that's the concept, either positive or negative. So if a source charge is positive, so electric field goes outward direction. If source charge, these are called source charge, is negative, so electric field to field direction toward the source charge. Towards source charge is inward, and if I say the outward force means the source charge is positive. Okay. So inward is means the source charge is negative, and outward means source charge is positive. Okay. So here is the SI unit, that is force per coulomb, that is the SI unit is Newton per coulomb. Very easy. And this is a vector field of yes. Okay. Next we discuss the dipole. Okay, what is a dipole? The important concept we discuss. Dipole. So dipole name suggests that there is a two pole. Okay, naming suggests that that is two pole. One is positive, other is a negative. So two pole means two charges Q and Q. If same magnitude, we say that is a 10 coulomb positive, the 10 coulomb negative charge. Okay, that is called a dipole. They are the two charges, but they are in different polarity, but their magnitude are same, and they are separated by some distance r. Okay, so if the r divided by 2, the center point half of the r, exact half, that is r by 2, that is r by 2, exact half point is called dipole center. It's called dipole center, DC, dipole center, and where we get a moment, actually, we get a moment, dipole moment dipole moment, that is a vector P, that is minus to plus direction actually. The dipole moment is a vector field, obviously, directed by minus charge to plus charge direction. Okay. Now, what is the value of dipole moment? That is R times Q, or QR. Okay. The direction of, suppose, B cap, dipole moment direction is a vector. Okay. And some book refer as NCERT book as a P equal to 2A Q, that is the A. And that is 2A, that is also equal to R. There NCERT book refer as that distance is 2A. And the midpoint of that distance is, that is the dipole center, that is A, and that is A. Okay. And there is a dipole moment associated, if a dipole was placed in electric field, external electric field. So dipole experience some torque. If a dipole placed in external electric field, so dipole experience some torque. The rotating vector, the tau, okay, the tau, that is also equal to, this is a dipole external torque, that is equal to P cross E. We derive that equation, okay, in previous lecture. I refer that the piece for the previous lecture, okay. That is a summary class, okay. So that is a P cross E, the P the represent dipole moment is the external electric field, and tau is the torque. If a dipole placed in like external electric field, the dipole experience some torque, that torque the value tau equal to P cross E. Okay. And if electric field calculation, okay, in dipole center, equatorial corner, dipole axis, we calculate these two also. Okay. Again, we calculate electric field, calculate electric field on dipole axis and equatorial plane. Okay. To solve these two, obviously. Okay. So, what is the value of electric field in dipole axis? Okay, dipole axis means is a plus charge, that is a minus charge. Okay. So, that is the separation, that is R. That line represent dipole axis. So, calculate electric field at that point, or that here, or that here. Okay. That is the calculate electric field on dipole axis. So, we can solve these. Okay. Please follow the previous lecture. Okay. We'll solve these. Or what is the value of dipole center from distance? Okay. So we get the electric field E, that is equal to 2QR, and divided by 4 pi epsilon naught R square minus H square whole square. If I place the electric field direction E, that is equal to 2P, and the P also the vector, and E and P are in this, actually P in that direction. Okay. So that is 4 pi epsilon naught R cube. So if there is the R is much greater than suppose A. What is the assault? Actually, that is the represent A. Okay. That represents A. That is actually 2A. Here to there has to be A, and after that is A. And here that's equal to these are called R. Okay. So these are the R. If I to please follow the previous lecture, okay, I can't calculate it. That's it. Take too much time, and okay, solve this. Okay, please follow this. And now we discuss the dependency of electric field on R, and what is the E, what is the dependency there. Okay. Now we another discussion is electric flux. That's very important in Gauss's law. Electric flux. Flux is very important. What is flux? The flux equal to number of electric field crossing per unit surface area. That is V dot dA. Okay, the integration if I indicate that, okay, as the electric flux. And that is a flux is a scalar quantity. That is, so if a flux is a scalar quantity, so we get the value. A unit of flux, that is electric field unit, that is SI unit. So that is the SI unit of electric field is a Newton per Coulomb, and that is the area, small area, that is a meter square, that is the electric flux. And there is a three type of another concept we discuss, that charge distribution. Uh, Charge distribution. Okay, so there's three type of charge distribution: line charge distribution. Okay, surface charge distribution and volume charge distribution. So line charge distribution represent lambda, surface represent sigma, and volume represent rho. That is a delta Q by delta L for length, delta Q by delta A for area, delta Q by delta B for volume. Now we discuss the another important concept is called Gauss's law. Okay, so Gauss's law, we discuss very important topic, Gauss's law. Okay, so Gauss's law equal to pi equal to Q by epsilon naught. What is the value of Q? If I consider a sphere, the Q place here, that is a Q. This surface is a Gaussian surface enclosed by charge, enclosed charge Q, E and C enclosed. That is a Gauss's law. Now that's phi equal to E dot dA dipole, that is Q enclosed by epsilon naught. We derive actually Gauss's law from Coulomb's law, and Coulomb's law to Gauss's law, very important. And here discussion from application of Gauss's law and sorry, Gauss's law. Okay, and here we discuss the three type of flux actually. Okay, the flux, positive flux, negative flux, and zero flux. Discuss. Okay, what is the value of zero flux? We refer the all lecture in I button. Okay, please follow this all lecture, and you can follow this lecture. I think that if you clear the concept, okay, and enough for boards and NEET and JEE exam, this concept. If you follow these lectures, okay? And now the application of Gauss's law, we discuss three types of application. First, on cylindrical symmetry, cylindrical symmetry, cylindrical symmetry for line charge distribution, line charge. Second is the surface symmetry, surface. Let's see, represent actually, these are represent also surface charge. Here we discuss the volume symmetry, um, spherical symmetry, not a volume symmetry. That is actually spherical symmetry, and that is a volume charge. But these volume charge actually, we solve this spherical symmetry with the help of surface symmetry. Okay, area symmetry. If you see that in previous topic, yes, spherical symmetry. This also solve that with the help of the area symmetry. Okay, you don't need any volume symmetry here. And previous we discussed here, see that there's a cylindrical symmetry and there's a planar symmetry or called the surface symmetry. Okay, there's an application of Gauss's law. Okay, and we solve some basic some numericals. Okay, and I think there's a enough. Okay, I recommended please follow the previous lecture. This is a summary class. This is not a all lecture discussion here. Please follow the previous 10 to 12 lecture I think made it, and that lecture is enough for these board exam and the NEET exam or competitive exam. Okay, actually not means enough. There is no limit actually. I can make a 20 to 30 lecture all this. But that is not enough. The enough is enough means that is some point actually. If you study the NCERT books and if you solve the previous year's paper, that's mean enough. If you follow the lecture, write down the notes, and you follow the rigorously studies, and follow the NCERT books or any other books or reference books, HC Verma book, very good reference. And if you practice and take a time and give the time to the study, I think it's easy to clear any competitive exam. Okay, so please follow the lectures, and you meet the next class and new topic and new discussion. Thank you.